Jai Hind students. In today's lecture, we will discuss mathematical tools and we'll start with differentiation. It's a very important topic. Now look, in physics, while deriving certain articles and while solving certain numericals, we require certain mathematical tools without which the articles or the numericals can't be solved. So in +1, whether you opted for medical stream or for non-medical stream, it is mandatory for each and every student to know about differentiation, integration, trigonometry, then logarithm, then exponential series, and then obviously quadratic equation, binomial theorem, and the graphs, various cases. So these are some of the tools which we in physics will be frequently using, right? So although it is not in your curriculum, but being a science student, and if you really want to enjoy this subject of physics, you need to be aware of these mathematical tools which we are going to discuss from today's lecture, right? So we'll be covering each and every topic subsequently. So in the next few lectures, we'll try to cover this mathematical tools, right? So again, for non-medical students, they will be dealing with differentiation and integration in +2 mathematics. In +2 maths, 60 to 70% of the entire mathematics syllabus comprises directly or indirectly is related to differentiation and integration and application, derivatives and integration, right? But especially for the medical students, please watch the video very, very carefully and try to practice whatever is being taught to you, right? Especially differentiation and integration. These are two very, very important tools. It is also known as calculus. While deriving equations of motion also will be making use of differential calculus, right? As well as integral calculus. So, without wasting any time, let's start with differentiation. So, before we start with differentiation, we need to be aware of all these things. So, in today's lecture, we won't be able to discuss the formulas of differentiation, but we will start from the basics. What actually differentiation is? What is its physical significance? Right? How will you geometrically interpret it? So for that, let's start with constant. So students, you all are aware, constant means during any mathematical operation, its value won't change. Its value will remain fixed. So that is constant, right? On the other hand, variable means a quantity which can take any value, whose value can change. That's for you, constant as well as variable, right? Now, function. In order to discuss this function, let me give you an illustration. Suppose y is a function of x. It is represented like this. Y as a function of x, it's represented like this. So basically, x and y both are variables, but students, x over here is independent variable, while the value of y which depends on x is known as dependent variable, and it is read as y as a function of x. So for any value of x, y will have a definite particular value. So that is the reason why the value of y depends on x, and that is the reason why y is known as an dependent variable. It is known as a dependent variable, right? Again, let's take some example. Let y is equal to, let us consider y is equal to 3x square minus 2x plus 1. Suppose for x equals to 1, the value of y would be like this. We can easily solve it. So it is 3 minus 2 plus 1. So that would be equal to 2. Isn't it? Now again, for x equals to 2, let's get the value of y. So 3 into 2 to the power 2 minus 2 into 2 plus 1. So that will give a 12 minus 4 plus 1. That is 8 plus 1, which is 9. Now look at these examples. for x equals to 1, y has got a definite particular value of 2. For x equals to 2, the value of y is 9. So therefore, x can attain any value, but corresponding to a particular given value of x, y will have a definite value. So therefore, students, x is an independent variable, while the value of y, which depends on value of x, is known as dependent variable. So if x is changed, there will be a corresponding change in the value of y. So therefore, y is said to be a function of x. Y is said to be a function of x in such a scenario, right? So let us now discuss what changes it will produce when x is changed by a very, very small amount, and then slowly and steadily we will come to derivative, meaning of derivative or differentiation, right? So what to do is, let us consider y is equal to fx. Let us consider y is equal to fx. Let this be equation number y. Just now we have discussed, on changing the value of x, the value of y will also get changed. So if the value of x is given some increment, small increment, suppose the value of x is changed from x to x plus del x. Here del x represents small change in the value of x, del x, it is known as del x. So if the value of x is changed to x plus del x, then there will be corresponding change in the value of y also. So the y value will now get changed to y plus del y, right? So students, when a small increment is given to the value of x, suppose in the above equation, when the small increment is given to the value of x, this is a small increment I am talking about. Correspondingly, the value of y will also get changed. So now the value of y will be written as y plus del y. Put this as equation 2. With the change in the value of x or with the increment in the value of x, there will be a corresponding increment in the value of y as well, because y is a function of x, right? Now what to do is, let's subtract these two, second minus first. What you get is y plus del y minus y. It will be equal to f x plus del x minus fx. So after solving, what do you get? Del y is equal to f x plus del x minus fx. Now dividing throughout by del x. Let's divide it throughout by del x. So divided by del x on both sides. What we get is del y divided by del x is equal to f x plus del x minus fx divided by del x. It's okay? Now students, if the value of del x approaches to 0, if you take the limiting case, del x actually represents a small change in the value of x. Now, if del x approaches to 0, so in the limiting case, when del x approaches to 0, this symbolizes it can't be 0, it approaches to 0. It is vanishingly small, infinitesimally small. Obviously, del x can't be 0, it is approaching towards 0. In that case, it can be written like this: del y by del x approach to 0, and it is limit del x approach to 0, f x plus del x minus fx divided by del x, right? So, in calculus, this term is represented as dy by dx and is known as the differential coefficient or the derivative of y with respect to variable x. I repeat, when del x approaches to 0 in the limiting case, then limit del x approaches to 0 del y by del x in calculus is represented by dy by dx. This is actually the differentiation, or rather differential coefficient or derivative of y with respect to variable x. So dy by dx is the derivative of y with respect to x. This is how it is read. So what is differentiation then? What is differentiation then? The derivative of y with respect to x. The process of finding the differential coefficient or the derivative of y with respect to variable x, that is known as differentiation. Students, actually it represents the small change in y with respect to a small change in another variable x on which y depends. So that's differentiation point, right? So now what we'll do is we'll try to graphically interpret this dy by dx. We'll try to find out the graphical interpretation of dy by dx. For that, what to do is, suppose we are considering this one, y is equal to fx. A graph is plotted between x and y. And let us consider this to be x-axis, this to be y-axis. Let us consider the graph obtained as a parabola like this. Let us consider this to be point P, having coordinates of x and y, and this to be point Q. So this can have a coordinate of x plus del x and y plus del y. Just now we have discussed, on giving small increment in x, there would be a corresponding small increment in the value of y as well, right? So suppose this is point P and point Q, very close, and having coordinates of xy and x plus del x and y plus del y respectively. Now what to do is, students, let's try to graphically interpret it. Obviously this is x, this distance is x plus del x. So what about this distance? This is del x. Isn't it? From the diagram it's pretty clear. Now also let us consider this one to be y and this distance, it is obviously y plus del y. So students, what about this distance then? It is del y. It is del y, right? So it can be considered to be a triangle. This may be considered to be a right angle triangle, and this may be considered to be an angle theta, and this may be considered to be a straight line like this. Now what needs to be done is concentrate on this particular diagram. We are aware to find out the slope of a straight line, isn't it? So let's try to find out the slope and then let's try to interpret it. So what we do is, slope of this graph, you are aware, slope is given by tan theta. Tan theta, it's perpendicular by base, isn't it? Which is y2 minus y1 divided by x2 minus x1, which in this case would be y2 minus y1. This is x1, this is x1 y1, this is x2 y2. So y2 minus y1, that is y plus del y minus y divided by x2 minus x1, which will give us x plus del x minus x. So what do you get? It is equal to del y by del x. This proves the fact that slope actually is given by tan theta, which is, see, perpendicular by base. Perpendicular is del y, base is del x, right? Now let's try to interpret it. Now suppose, students, point Q comes closer to point P. Then del x will start decreasing, correspondingly del y also start decreasing. Again I repeat, consider a scenario when point Q approaches point P. So both are approaching towards each other. So in that scenario, when point Q becomes closer and closer to point P, then the value of del x decreases and corresponding the value of del y will also decrease. So in the limiting case, when P and Q will be almost coincident with each other, then del x will approach to 0. Again repeat, as point Q comes closer to point P, del x, del y both will start decreasing. So in the limiting case, when point Q almost coincides with point P, then del x will approach to 0. And in that case, at that particular point, a tangent drawn at that particular point will give the slope of the graph. Clear? So in the limiting case, that is when del x approaches to 0. In that case, del y over del x, when del x approaches to 0, it is dy by dx. This is the differential coefficient of y with respect to variable x on which the value of y depends. So what do you geometrically interpret from this? That dy by dx represents the instantaneous change in the value of y with respect to x. So that's the meaning, that's the geometrical meaning of derivative of y with respect to x. Clear? So now let's try to physically understand physical significance of differentiation. Let's try to understand that. Just now I told you, when del y by del x is taken in the limiting case, that is when del x approaches 0, then it becomes the instantaneous rate of change of y with respect to x. Right? So now let's discuss the physical meaning of differentiation. The physical meaning of differentiation. I'll give several examples related to this. Now look, we are already aware of certain terms like velocity, like acceleration. As we are aware, in a non-uniform motion, what happens is the velocity of a body is random. With the passage of time, its velocity changes either in magnitude or in direction or in both, isn't it? So it won't be possible for us to get the exact value of velocity of the body at a given instant of time. But anyway, at a given instant of time, the velocity is known as the instantaneous velocity. So instantaneous rate of change of displacement with respect to time, that will give us instantaneous velocity. So in calculus, suppose the body covers displacement del s in time del t. Right? Let us consider a body to have covered displacement del s in time del t. In the limiting case, when the time interval is considered to be very, very small, it approaches 0, then it will be written as ds by dt. And student, this is actually the instantaneous rate of change of displacement with respect to time, and it is known as velocity. Actually, it is instantaneous velocity. Instantaneous velocity. Right? So this is one example. The instantaneous velocity is given by the time rate change in the displacement with respect to time, or differential coefficient of displacement with respect to time, or derivative of displacement with respect to time. Right? Another example. This one is the first one. Another example. When the velocity of the body changes per unit time, then that is known as acceleration. So instantaneous acceleration. Instantaneous acceleration. It will be given by A is equal to del V by del T, and limit would be del T approaches to 0. and this A in calculus will be written as dV by dt. So students, this represents the instantaneous acceleration. The differential coefficient or the derivative of velocity with respect to time, that is known as instantaneous acceleration. Clear? Let's consider some other example. Instantaneous power. Rate of doing work, that's power. So it can be written as limit del t approaches to 0 for very small change in the time, del w divided by del t. So instantaneous power may be written as differential coefficient of work with respect to time. So this is instantaneous power. So students, I sincerely hope that this concept must be pretty clear, right? So these are some physical quantities which may be expressed using calculus. Time rate change in the displacement is velocity. Differential coefficient of displacement with respect to time, that will give you instantaneous velocity. Differential coefficient of velocity with respect to time, that will give us acceleration. Differential coefficient of work with respect to time, that will give us instantaneous power. So here I must mention that the differentiation of a variable is always with respect to another variable on which the first variable depends. So students, what about the differentiation of any constant term? Constant. Obviously constant, its value won't change even when other quantities may change with the time, but constant term, its value will remain fixed. So there won't be any change in the constant value, isn't it? So the differentiation of any constant term is always 0. There is no change in the value of constant. So remember, this is a very basic thing. So differentiation of constant is always 0. So before I conclude this session, just 2 or 3 formulas we'll discuss. There are mathematical verification of these formulas as well. But being a physics teacher, I will be concentrating only on the formulas, right? In maths, you will study about the mathematical verification of these formulas. But as I have told you, these are the formulas which are very important, which we will be frequently using in derivation of certain articles as well as in numericals, right? So, first important formula what we have discussed is differentiation of any constant is always equal to 0. This is known as differentiation of any constant with respect to x. This is a symbol for differentiation of a function with respect to x, right? Another very basic formula. Differentiation of x to the power n. X to the power n. It is equal to n x n minus 1. This is the formula. This is read as differentiation of x to the power n with respect to x. It is n x to the power n minus 1. We'll discuss various quotients in the next episode. In this particular session, we are just trying to discuss the formulas. Third, differentiation of constant multiplied by x to the power n. Now look, constant, whenever it is multiplied with some function, then the constant can be taken outside the differentiation. So it will be like this. And now applying this formula in the above, in second, we can write c being constant will be taken outside the differentiation, and rest the differentiation of xn with respect to x is n x n minus 1. Clear? Fourth, differentiation of u plus minus v plus minus w. And suppose u, v, w are the function of x. U is a function of x, v is a function of x, and w is a function of x. So simply we will write like this. Differentiation of u with respect to x plus minus differentiation of v with respect to x plus minus differentiation of w with respect to x. Right? Simply try to open the bracket and you will get the result, right? Fifth, this is a product rule. Suppose u and v are the functions of x, and suppose product of u v. We are supposed to find out the differentiation of u into v, where u and v both are functions of x. So consider this to be the first function, this to be the second function. So the formula is first function multiplied by differentiation of second function plus second function multiplied by differentiation of first function. This is known as the product rule. This is known as the product rule. And there's another one which is known as the quotient rule. Let's discuss that as well. So these are basic formulas, and all these formulas can be mathematically justified as well. And we'll apply these formulas in the next session, right? So, last one is quotient rule. Quotient rule. So, quotient rule is, again, let u is a function of x and v be also a function of x. Then differentiation of u by v would be equal to, like this, denominator square, then denominator multiplied by differentiation of numerator minus numerator into differentiation of denominator. This is the formula. This is known as the product rule, and this one is known as the quotient rule. There are some other formulas for trigonometric functions as well as for exponential logarithmic functions. That also we'll discuss, but that is in the next episode. So students, I sincerely hope you will go through these topics in detail and you will try to learn these formulas. We will try to apply these formulas in the subsequent session. Right? Till then, bye-bye.